Leading a startup team? Whether you're delivering a sugar rush, stocking coffee, or getting a regular delivery of snacks, Office Depot has solutions that fit every startup culture, from getting those first business cards and stationery to ordering fleece pullovers with your new logo. To learn how Office Depot and the California Technology Council have partnered to bring you savings on all of these startup essentials and more, go to californiatechnology.org/member benefits. I'm Daniel Levine, and this is the Bio Report.
Psychedelics have long been viewed as having potential to treat a range of mental health disorders, including depression, addiction, PTSD, and ADHD. Government policies, though, have long impeded studies of their benefits. Mind Medicine is developing a pipeline of therapies based on psychedelics in the hope of developing needed medicines for psychiatric conditions. Its lead experimental therapy is an ibogaine-derived molecule for the treatment of opioid addiction. We spoke to Steve Hurst, founder and CEO of MindMed, about the potential for psychedelic-based medicines, what's known about them to date, and the challenges of working with these substances. Steve, thanks for joining us.
My pleasure, Danny. It's a privilege to be here.
We're going to talk about your company, MindMed Psychedelics, and your efforts to develop both hallucinogenic and non-hallucinogenic therapies. I think Michael Pollan's book, How to Change Your Mind, brought to public awareness the science around psychedelics and their potential therapeutic uses, including addiction and depression. But perhaps you can begin with some context for people. Despite the government's treatment of these substances over these many years, there has been ongoing research. How well studied are these substances from a scientific point of view?
Well, I think the short answer is they are being studied at the moment under the supervision of the U.S. FDA and regulators over in Europe, which is great. It's great news. What isn't well known is that the research has been going on in this very high quality context for more than a decade now. And it really rolls back to Roland Griffith's early work at Johns Hopkins on the effect of psilocybin in alleviating the anxiety associated with the terminal diagnosis. I think his first publication came out in about 2006. That goes back to a number of years before that, when an organization was formed by Dr. David Nichols, who's actually a chemist, a number of years ago, called the Hefter Institute. And the Hefter Institute is a not-for-profit that is dedicated to generating rigorous, peer-reviewed, academically stringent data on the potential therapeutic benefits of psilocybin in particular, and more broadly, psychedelics, hallucinogenic compounds. We got into the field in a different way, in an opposite direction. We started working with an analog of a very hallucinogenic natural compound called ibogaine that was reported to have very strong anti-addictive properties. And we got involved with a researcher at Albany Medical College in 2009 that had been working on an analog of ibogaine that had been synthesized in an effort to eliminate the hallucinogenicity of ibogaine and eliminate the cardiovascular safety issues associated with ibogaine administration. Underlying that work, which was done by our founding scientist, Dr. Stanley Glick, was what I said was a brilliant insight at the time. This was in the early 90s, late 80s, early 90s, when he hypothesized that some of the medicinal properties that people had reported over the many, many years, centuries actually, of natural psychedelic compounds like psilocybin, perhaps they were not related to the hallucinogenic effect. And he saw ibogaine as particularly representative with respect to this hypothesis. So he worked with a medicinal chemist to create a library of analogs. These are synthetic organic compounds, so a chemist playing at the bench, changing various pieces of the backbone molecule of ibogaine to see if they could create a molecule that wasn't hallucinogenic, that did not have cardiovascular toxicity, but retained the anti-addictive properties of ibogaine. And they succeeded in doing that in the laboratory. So all the laboratory data supported the notion that they had essentially created a compound with strong anti-addictive properties without the hallucinogenic effects of the parent compound of ibogaine and without the cardiac toxicity of ibogaine. We started working on that project in 2009. After working on that project for a while and learning more about the work that was being done at the Hefter Institute with psilocybin, the work that Roland Griffiths had done at Johns Hopkins University, looking at other investigators that were getting interested in the psychedelic compounds as potential therapeutics, it really occurred to me that there was a much broader class of potential medicines coming out of these two endeavors. Our work on the non-hallucinogenic analogs and other people's work on the highly hallucinogenic psychedelics that were being dosed at what we call experiential, meaning they're having a mystical or a transformational experience, a psychedelic experience. That there's actually a continuum, that there's the potential for medicines that are not hallucinogenic but have the medicinal properties of hallucinogens. And there's also, as the data has come to show, a great deal of potential in hallucinogenic compounds at addressing some of the biggest unmet medical needs that we face in addition to addiction. We're also looking at mental health issues, anxiety issues, depression, PTSD. There's an organization called MAPS that's been working with MDMA, also known as ecstasy in the popular culture, in the treatment of post-traumatic stress disorder. And they are in a clinical trial that is targeting approval of MDMA for the treatment of post-traumatic stress disorder under FDA supervision right now. And this is tremendously promising in addressing what we know is a very, very challenging disease, and one that all too often leads to people that have, for example, provided tremendous service to our country, but end up taking their own lives because they can't get any relief from revisiting the trauma through this post-traumatic stress disorder.
How exactly did MindMed come together?
We spent a fair bit of time working on de-risking the 18MC project, the addiction project, meaning we really needed to put the drug into human beings and confirm what we saw in the animal studies, that 18MC was not hallucinogenic, that it posed acceptable cardiovascular risk, acceptable meaning like any medication. It shouldn't cause heart attacks or induce cardiac arrhythmias, and demonstrate that we could actually effectively dose it in a human so that the drug was eligible for further development, meaning going into later stages, more normal healthy volunteer studies, which is where we started, moving into various forms of addiction, opioid use disorder, nicotine dependence, methamphetamine addiction, cocaine addiction, and the like. And we succeeded in achieving that first in human work in about 2015, 2016 timeframe. And at the time, we had been working very closely with the National Institute on Drug Abuse through a pretty significant grant that we'd been given to essentially prepare 18MC for that first in human work. But they wanted us to continue the work with 18MC in cocaine use disorder, cocaine addiction. About that time, news really started to come out about the opioid epidemic in America and the consequences of the opioid epidemic. When we had started the project in 2009, we were aware of the tremendous growth in per capita use of opioids in the United States in the previous decade. Basically, between 1999 and 2009, the per capita use of opioids in the United States had gone up by a factor of 3.5, which is a very, very significant increase in the use of any kind of a drug or medication. So we were aware that this was going to be a potential problem. None of us, however, saw what started to be reported in 2016 and 2017 in terms of the opioid epidemic. We never expected the deaths from opioids to surpass deaths from accidents, for example. And we never expected the economic impact of the opioid crisis in this country to be as significant as it is. And I think you probably are aware that it's been reported by government accounting offices that the opioid epidemic is costing the U.S. over $500 billion a year in lost productivity and expenses associated with the epidemic.
How big a market opportunity for a drug do you think there would be?
Well, in addiction alone today in the United States, if you look at treatment, and this includes recovery programs and the like, the costs associated with those programs, that market size, is over $30 billion a year in the U.S. That includes medications, it includes recovery programs, it includes counseling. The issue with addiction is that you probably need a comprehensive approach to really get long-term benefit to the patient. In other words, we don't believe that a single drug is, it's going to be a magic pill and suddenly we're going to eliminate the opioid crisis. We think that we need improved medications, and we hope that 18MC turns out to be an improved medication. We have very high hopes of it, obviously. But because there's such a strong social component, psychosocial component, counseling is also important, and that means sometimes more comprehensive counseling, like the kind of thing you get in recovery programs. So what we're looking at is improving outcomes and getting a better result for patients than what we're getting today. In addiction today, the treatments and the approaches today, probably the best of the best are about 1 in 5 patients get long-term benefit, meaning more than 12 months of benefit from having been under treatment. And we really need to improve that. That's just a number that's not good enough.
What's understood about 18MC's mechanism of action? How does it work?
So you start with an understanding of what addiction is and what it is not. And one thing it is not is an issue of willpower in people that are truly addicted to a compound. It's actually a brain disease. The hallmark of the brain disease is the dysregulation of a chemical in the brain called dopamine. And most people have heard of dopamine. It's usually associated with things like Parkinson's disease and what we call motor neuron diseases and the like. But dopamine is just as important as the other chemical in the brain that most people have heard of, which is serotonin. And serotonin is kind of your happy, sad drug. We talk about, serotonin and serotonergic therapies for treating things like depression and the like. So I usually term that as kind of your happy, sad drug in the brain, your natural chemical in the brain that is responsible for those feelings. Dopamine in the reward pleasure center of the brain is responsible for sensations of pleasure and sensations of distress. It's a very different chemical neurotransmitter than serotonin. They work somewhat together in the brain. You need both. You need normal levels of both. When you have addiction, you do not have a normal background level of dopamine in the reward pleasure centers of your brain. The brain has basically adjusted itself in response to being stimulated so much by the addictive substances that the body can no longer produce a normal or baseline dopamine level without the assistance of the addictive compound, whatever it is. It's all the same mechanism. And certain behaviors drive this too. Gambling addiction, sexual addictions. Everything's being driven by this central mechanism in the brain of the dysregulation of dopamine in the reward pleasure centers of the midbrain. So we take a disease-centric approach in looking at addiction. And 18MC actually addresses this dysregulation of dopamine in the reward pleasure centers of the brain. And what we believe is happening is that with the administration of 18MC, it is essentially resetting parts of the reward pleasure center of the brain so that there is a natural upregulation of dopamine release, restoring essentially normal baseline levels of dopamine and alleviating the biggest problem in addiction, which is cues that induce craving. And everybody talks about this. You know, people that you've been around people, or maybe you've been through it yourself, where you've stopped smoking, for example. And people will talk about, you know, they're really craving a cigarette right now. And that craving sensation is often associated with an environment where normally they would have smoked. They just finished a meal. Customarily, they would have had a cigarette. They finished the meal, and now they're craving a cigarette. And that's being driven by this dysregulation of dopamine in this part of the brain. 18MC seems to create more of a natural resistance to the creation of craving that's associated with in what we call environmental cues. And I don't want to get overly technical here, but I got to use some of this jargon to really get down and explain the issue. And what we know about the brain and the way it functions in neuroplasticity is that the brain is very adaptive. It's a very adaptive organism. It's constantly adapting to its environment. And one of the best examples of this is I like to talk about people, you know, the first time you drive to your new house and the first time you drive from your new house to your place of work, you kind of have to pay attention to street signs, directions, maybe you're using your GPS. And it doesn't take long before you're essentially doing that drive kind of on autopilot. You don't have to concentrate to make the trip from your house to your work or back again because your brain has learned that path, that way forward, if you will. And it's put it into a background processing in the brain that some people refer to as sort of your fast thinking process. It's happening, you're doing it, you don't have to think about it, it doesn't take a lot of conscious thought. And one of the examples of how ingrained this becomes is when I do this all the time, I throw my dry cleaning in the back of the car, and I get in the car to go to work, and I get a phone call, and I take the phone call, and I forget about the dry cleaning in the back seat that I was going to drop off. I get to the office and install the back seat. Because I had to concentrate not to make the drive from my home to the office in order to drop off the dry cleaning. My concentration got interrupted by something else I had to concentrate on, and I forgot all about the dry cleaning in my back seat. That's a classic case of how neuroplasticity works and how we benefit from it. But it can be co-opted, and that's what addiction does. Addiction is basically creating an environment where neuroplasticity in the brain is causing the brain to adjust to that new environment. Once it learns that new environment, it wants to do what's familiar to it. And that's part of what's going on in addiction. And what we think 18MC is addressing is this underlying central cause of dysregulation of dopamine in the reward pleasure centers.
You're preparing to conduct a phase 2 study. How would the clinical trial be structured, and what would the endpoints be?
So our first inpatient study, and just for the sake of the audience here, phase 1 studies are normally done in healthy volunteers. These are your early studies to figure out dosing and what the patients can tolerate, what's well tolerated, what's less well tolerated. Most of that work is done in normal, healthy volunteers. When you get to later stages, phase 1B studies are often done in patients, although they're not done in significant numbers. You're just sort of looking for a signal. Phase 2 studies are almost always done in patients where you're, again, continuing to explore the safety of the drug in a patient population that's much larger than you have previously. But you're also looking for an efficacy signal, an indication that the medication is having the benefit that you intend, that you're getting the outcome that you're looking for. And as you progress these studies, the numbers of patients get to be larger. You're looking at a more diverse cross-section of the population, and you're trying to prove that the treatment group is doing better than the group that's getting a placebo. Basically something that looks exactly like the treatment is being administered exactly like the treatment, but doesn't have the active medication in it. When we plan the phase 2 study for 18-MC in opioid use disorder, one of the things that we have taken a very careful look at is what are the shortcomings in current treatment approaches? And I'll give you an example. If you go into the emergency room and you're showing symptoms of opioid withdrawal, the current standard of care is to administer the patient methadone, which is an opioid. It's a prescription medication. It's used a great deal. Most people have heard of methadone, but it's still an opioid. It's doing exactly what the heroin was doing, or the fentanyl, or whatever the opioid was that the patient was addicted to or is addicted to. It's just easier to prevent undesirable health outcomes using something like methadone under supervision of a physician, based on approved label guidelines and the like. It's a safer administration of an opioid to alleviate the symptoms of withdrawal. And when you go into a detoxification under medical supervision, what they do is they start to reduce the amount of methadone that you're getting over a period of several days. And eventually you're discharged. You're not discharged with a prescription for methadone going forward most of the time. They want the patient to come back in a few days, 5 days, 10 days, and get a maintenance drug. The one that's out there right now is called Vivitrol. It's a long-acting naltrexone injection that lasts up to a month. And they want the patient to come back and get a dose of Vivitrol that will help them to maintain their opioid-free status for a period of weeks. If you give a patient methadone when they come into the withdrawal center, you can't discharge them having given them this maintenance medication, the naltrexone. And the reason is that if they have opioids in their system, which methadone is, if you give them naltrexone, they'll go into what's called a rapid detox, and it will create a very unpleasant and uncomfortable experience for the patient. So they want the patients to come back in. Now, where they're failing is they leave the detox unit, they haven't gotten their maintenance therapy, and because they haven't gotten their maintenance therapy, they relapse before they get back in because the cravings get really bad, and then they turn back to using. So what we're doing is we're going to be looking at 18-MC in combination with the treatments that are being used today to see if we can get better outcomes. More patients that are getting on Vivitrol before they leave the detox unit, more patients that are getting better results on Vivitrol long term so that they're not relapsing and going back to using. So that's essentially the study design. It's called medication-assisted withdrawal and medication-assisted maintenance. And we're going to test 18MC in combination with those current approaches to see if we get better results.
You're also developing an LSD microdose for ADHD. There's been some buzz around the use of microdoses of LSD by workers in Silicon Valley to enhance their concentration. What's actually known about the potential here?
A great question, and we asked the same question. The reason why we're working in the area is because there is so much buzz. But right now, it's as much urban legend as it is anything else. And what we want to do is, apply our expertise to actually generating data that tells us, does this really work or not? Is it a substitute for Adderall? It's been alleged by a number of people. Probably, I don't know what the numbers approach, but many people have said that, microdosing LSD got them off of Adderall. May or may not be true. So we want the data. We want to look at the actual data and make a decision about whether or not developing a microdose form of LSD for treating adult attention deficit is in fact a worthwhile thing to do.
And what's the opportunity?
Well, I think that something around 20% of the adult population has some kind of an attention deficit issue, or at least they feel that they have an attention deficit issue. So, 20% of the U.S. adult population is a pretty significant incidence of the illness. And as to what portion of that market we might have access to with microdose formulations of LSD would be kind of to be determined. But if it's as good or better than Adderall, if it's as effective without the side effects of Adderall, I would suspect that that's a market that we would be able to essentially replace with something like a microdose form of LSD.
You're also preparing for a phase 2 study here. What would the clinical trial look like?
In ADHD, a great question, and I am not really the one to answer it. We are at the very early stages of this project. Our preliminary work is going to be done in Switzerland, and I think that work is going to go a long way towards giving us the answers to the question that you asked. Ultimately, what would as we call it in the trade, a label claim look like? What would the dosage form look like? What's the tolerability? And is it more effective in a certain subset of patients, a certain segment of the population, than in another segment of the patient population? These are all the questions that we need to generate the data to answer so that we ultimately get to what would microdosing LSD look like as a prescription medication. Don't have the answers today.
What kinds of intellectual property issues would there be around microdoses of LSD, and is this something you could protect with a patent?
Well, one of the things that I've spent a lot of my career doing is building intellectual property positions around what we call off-patent drugs. So there are multiple opportunities to establish intellectual property, to create a position that slows down, prevents competitors for some period of years. The obvious one in our industry is the generic drug. Generic drugs can't come on the market if there are patents that are listed that cover certain aspects of a drug that is on the market. And those kinds of patents are not limited to a patent on the active molecule itself. Those are called composition of matter patents. Other types of patents are useful in getting that kind of protection. So what we do is we take an approach of, we look at everything around what we're doing and where the opportunities are for invention and discovery, and then we take those inventions and discoveries and turn those into an intellectual property position that is much broader than you would achieve with a single patent covering a composition of matter. And I've been pretty successful with this strategy over the course of my career, and we're pretty optimistic that we'll be able to do the same thing here. But it all starts with data. You have to get the data in order to establish the intellectual property position. You have to get the data to know if you can safely administer anything to a person, and you have to get the data to know if you can get the desired outcome by safely giving a patient that drug.
Now, what kind of regulatory hurdles have you faced in working with these substances?
The issue with Schedule I drugs today is less about the regulators per se, in other words, the Food and Drug Administration or the European Medicines Agency, than it is about the licensing of the facilities to handle the compounds themselves. And these licensing requirements are strict. They add expense, they add cost to the process, but they're also essential because what they're designed to do is to prevent diversion of these substances from what is the intended use, in this case in clinical studies with humans under the supervision of regulators, as opposed to somebody walking in and grabbing, 100 micrograms of LSD for their lunch break. And that's the biggest issue that we deal with right now is a lot of the people, the vendors that work in the development of new medicines have not gone to the trouble or expense to become licensed to handle Schedule I substances, which is what all hallucinogens are at this point. And that means that we're limited in the organizations that we can work with, and it adds expense and some time to the project because once in a while, we need to work with the vendor and they're full up for some period of time. We can't get into their schedule for a number of months, and we incur some delays as a result of that. That's the biggest obstacle. The regulators have really taken let's develop the data and let's look at the data. If psilocybin is shown to have a medicinal benefit in a well-designed clinical study, and it has a statistically significant outcome in terms of the difference between psilocybin and a placebo, and the safety profile in the patient population is one that shows that the drug is well tolerated for the condition you're looking to treat. FDA has basically said we will consider that for approval. The greatest, I think, indication to date about the acceptance of these types of medications by regulators was the approval last year of S-ketamine, which is a nasally delivered form of ketamine, which has been in the past a Schedule I drug. It's been approved for certain narrow medicinal uses as a type of an anesthesia. Ketamine on the street is known as Special K. It's definitely got a reputation out there on the street, but it's also an approved compound approved by the Food and Drug Administration for treatment-resistant depression patients. And that approval of S-ketamine just came out last year, so we know for a fact that the agencies will consider these compounds. If the data supports an approval, they will actually move towards an approval, and that includes not the two approval components of a drug in the U.S. are the advisory committee, which is made up of experts in the field that review all of the data and make a recommendation to the commissioner of the Food and Drug Administration, and then the commissioner of the Food and Drug Administration acts on that approval, either by accepting the recommendation of the committee or rejecting the recommendation of the committee. And the commissioner's got a pretty good record of not necessarily taking the recommendation of the committee. But in the case of S-ketamine, both things happened. The committee approved it. They were in favor of it being approved, and FDA did approve it, and Johnson & Johnson now markets that compound as a prescription medication for use within a clinic setting, meaning supervised the entire time that the patient is being administered the drug and under the influence of the drug. So it's an in-clinic medication.
How would you say the scientific community and regulators' attitudes are changing towards the potential therapeutic benefits of psychedelics?
I think that because there's still significant unmet need on the part of patients, I think they're much more receptive than certainly they were 20 or 30 years ago. But we know that we're not doing a good job of treating mental health, certainly in this country and probably in the world in general. We know that we're not doing the best job in terms of treating substance use disorders, addictions. These are the largest unmet medical needs in the world. And I think that an acknowledgement that we need to be looking elsewhere, looking in places we haven't looked before, is very much the attitude today. And I think that the agencies will never suspend their obligations to the public trust in terms of safety and efficacy, making sure that, in fact, these are, quote, proven features of an approved medication, that it's safe for the patients, it's intended to be used in, reasonable protections are in place to make sure that it doesn't get misused or abused in some way, and that you're actually getting the outcome in the patients that you're looking for, or at least in a significant number to where it justifies having the medication on the market. And I think that attitude, which is one of reason, of rational conduct, has essentially replaced the paranoia and the fear born out of the 60s and the 70s in terms of attitudes towards hallucinogenics, psychedelics, and psychoactive medications in general. It's really a different world.
Steve Hurst, founder and CEO of MindMed. Steve, thanks so much for your time today.
Thank you very much. I appreciate it. It's been a pleasure.
Thanks for listening. The Bio Report is a production of the Levine Media Group. To automatically download this podcast each week, subscribe to our RSS feed or through iTunes or other podcast manager. To join our mailing list, go to levinemediagroup.com. We'd love to hear from you. If you want to drop us a line or are interested in sponsoring this podcast, send an email to danny@levinemediagroup.com. Special thanks to Jonah Levine, who composed our theme music, and the Jonah Levine Collective, which performs it.